In this video, we will start talking about triple integration. The first few problems I will do where the integrations are already set up for us. We are just going to do the antiderivative. Then eventually we are going to learn how to set up the integration and applications of triple integrations. In your first problem, the way your integration is set up, you know that you're going to first integrate with respect to the variable x. So let's go ahead and do it. And I will get x to the power 2 over 2 yz cubed are constant at this point with respect to these integrations. And then I have the values for x limits. These are -1 to 4. And then I'm going to go ahead and write the integration with respect to y and the integration with respect to z. So I will say dy dz. That's your first step. So let's go ahead and proceed with these things. So now your turn is to bring the constant out. That's always going to make your integration look easier and better. Always do that. And put the limits in. So if I put x equal to 4, I get 16. If I put x equal to -1, I get a positive 1 because -1 squared is positive 1. And then I will have yz cubed dy dz. Again, in the next step, take your constant 15 out. So you get 15 over 2. And we are ready to integrate with respect to y now. So we are going to get y squared over 2. Z is constant, so z cubed. And then limits for y are 0 to 2. I will integrate finally with respect to the variable z with limits 0 and 2. Inputting values and simplifying. So now we are going to put y equal to 2, so we get 4. And first, I will bring this 2 out and make it 15 over 4. Integration 0 to 2. As I said, put y equal to 2, you get 4z cubed dz. So now you take this 4 out and you get 15 outside. So integration 0 to 2, z to the power 3 dz. And then that becomes 15 times z to the power 4 over 4. Limits as usual between 0 to 2. So if I put z equal to 2, I get 2 to the power 4, so I will write it as 15 over 4 times 2 to the power 4. Recall 2 to the power 4 is 16, so you get 15 over 4 times 16, which is 15 times 4, and that is equal to 60, the value to your first antiderivative. So this work is pretty simple. We will do one similar problem before we start working on setting up the integration. So the limits this time are functions that are not necessarily constant numbers. But again, I'm integrating with respect to z first. So I will go ahead and do that integration. Because I'm lacking in z term, I'm integrating 1. So I get yz. And then the limits are 0 to y squared. And then you have integration with respect to the variable x, where the limits for the variable x is minus square root of 1 minus y squared, and it goes to square root of 1 minus y squared. And finally, I'm going to integrate with respect to y, and the limits for y are 0 to 1. So let's go ahead and work with this integration. First step, you're going to put in the values in. So I will say integration 0 to 1, integration minus square root of 1 minus y squared to square root of 1 minus y squared. And when I put z equal to y squared, I get y cubed. If I put z equal to 0, it doesn't contribute in anything. So dx dy. So now it's time to do the integration with respect to x. Again, you don't have any x term other than the constant function 1. So your integration is going to be y to the power 3x, limits being minus square root of 1 minus y squared to plus square root of 1 minus y squared. And it is required to be integrated with respect to the variable y. So we're going to put in the limits and write it as 0 to 1, y to the power 3 times square root of 1 minus y squared, minus from fundamental theorem of calculus, of the next limit is also a negative limit, so minus of square root of 1 minus y squared. And then finally, we're going to go ahead and say dy. So what happens? I get minus times minus, so that's a plus. So I get 2 of these things. I can bring this 2 outside. And this integration becomes y to the power 3 square root of 1 minus y squared dy. And this is a very clearly a very known integration to us. we're going to do a substitution, and this time substitution is going to be 1 minus y squared is equal to, say, t. So first realize that negative 2y dy, when the derivative is taken with respect to y, is going to be t, dt. But I see I can rewrite this integration as 2 times integration 0 to 1 y squared times square root of 1 minus y squared times y dy. So I need this term y dy in my expression. So why don't I go ahead and write it as y dy equal to minus dt over 2. So it has pretty much taken care of everything other than the limits. One other thing I would like you to understand, if 1 minus y squared is t, then 1 minus t is y squared. This is going to be necessary in the process of the antiderivative. Let's take care of the limits, y versus t, limits for y were 0 and 1. If you put in your expression y equal to 0, then you get 1 minus 0 squared, which is 1. So lower limit for t is 1. Upper limit for t is going to be 1 minus 1 squared, which is 1 minus 1, so 0. So let's rewrite this antiderivative in terms of t. So I'm going to go ahead and say that it's 2 times integration, as we have seen lower limits are 1 and upper limits are 0. Y squared, if you remember, I found y squared as 1 minus t. So I'm going to put that in, 1 minus t. And then square root of y squared, that was the substitution t. So it will be square root of t. Y dy was negative dz over 2. So what I do, I bring this negative 1/2 constant outside. And I said dz, you should have noticed that z doesn't make sense. So it should be t here. That's the variable of integration. So if I take this negative constant out, I get a negative 1 outside, and my integration is 1 to 0. What else I do? I write these terms as t to the power 1/2 after distribution minus t to the power 3/2. This is going to help me use the power rule of antiderivative, and I will get a dt. So now we are going to take the antiderivatives. So negative 1, antiderivatives are going to be t to the power 3/2 over 3/2 minus t to the power 5/2 over 5/2. And we're going to use the limits of negative, 1 to 0. So what I can do, I can write it as negative 1. See, putting t equal to 0 will not change anything, so I'm going to ignore that limit. I'm going to put in t equal to 1. But remember, you need a minus in front of that, and then you're going to start down the limit, writing the limits. So you get 1 to the power 3/2 over 3/2 minus 1 to the power 5/2 over 5/2. And next thing is just simplification. So minus times minus will already make it a plus, and no point of writing 1 as a multiplier. So I'm going to just go ahead and say that it's 1 over 3/2 minus 1 over 5/2, which is 2 over 3 minus 2 over 5. So it requires me to simplify. Common denominator is 15, so I'm going to multiply the top and bottom of the first fraction by 5, get 10, and top and bottom of the second fraction by 3, so you get 6. So 10 minus 6 is 4, so your final answer for this antiderivative is 4 over 15.